Okay, cruising right along. Let's hit problem 5, which is the last of the sort of, normal difficulty problems. So problem 5 is the final scene in the original Star Wars movie where Luke Skywalker is flying down a trench in his X-Wing fighter, which I will try to draw there. X-Wing fighter, more or less. Splayed wings, guns like that. And then there's R2-D2. Okay, so he's traveling along this trench, and the exhaust port he has to hit with his proton torpedoes is right there. And when he fires the torpedoes, they're going to fall a bit and do that. The torpedoes go faster than the X-wing. They're launched relative to the X-wing, and they fall. The Death Star's gravity is half Earth, so we have to figure all that out. And then this distance here is 6 meters. So let's find. Let's see. Let's start with velocity of Luke relative to the I'll say D for Death Star, for so D is the ground. There's Luke, and the torpedoes are T. Okay, velocity of Luke relative to the Death Star is they give us that he's moving 160 meters per second, and he's moving horizontally, so 160 I hat. When the torpedoes get launched, the velocity, or the initial velocity, velocity of the torpedoes relative to Luke initially is then 240 I hat meters per second. And then the acceleration of the torpedoes relative to the Death Star were given, and they go down, so negative and half Earth gravity, so we're going to say negative 5 J hat meters per second squared. So let's start by finding out how long it takes the torpedoes to fall the 6 meters. So delta y, or let's see, delta y for the torpedoes relative to the Death Star is negative 6 meters, and that's going to equal the initial velocity of the torpedoes relative to the Death Star. Or let's see, you know what? Let's back this up one step. That's going to equal the y component of the initial velocity of the torpedoes. So torpedoes with respect to the Death Star in the y direction initially, times t, and then right, plus 1/2 of the acceleration times time squared. So but the acceleration of the torpedoes relative to the Death Star in the y direction is negative, so we just do the minus 1/2 times 5, or actually I guess the way I should do this is to sort of show you everything step by step. So plus 1/2 acceleration of the torpedoes relative to the Death Star in the y direction times t squared. Okay, so parentheses around that now. Let's skip the parentheses, whatever. Okay, so switching colors now. Let's do red. So negative 6 equals this. There's no initial y velocity. The torpedoes launch horizontally. The X-wing is going horizontally, so this term here is all 0. Boom. So 6 equals acceleration of the torpedoes relative to the Death Star in the y direction is negative 5. Negative 6 equals negative, so really 1/2 times 5. So we just took the negative and pulled it over here, times t squared. And then t squared should equal 12 fifths. And so if you take, which equals 2.4, and that means t equals, where's my calculator? 2.4, hang on, square root of 2.4, boom, boom, 1.55 meters per second. Not meters per second, sorry, 1.55 seconds, right. That's how long it takes torpedoes to fall. Now, how far away does Luke need to be when he launches the torpedoes? Well, they need to cover, some distance d, right? Okay, so what's the speed of the torpedoes relative to the Death Star, or the velocity of the torpedoes relative to the Death Star initially? The x component. Oh, I'm making this so hard. So velocity of the torpedoes relative to the Death Star initially is, and again we're going to use the Giancoli rules. So VTD we can get by adding VTL and VLD, because you get the L next to the L. So VTL plus VLD. And I'm probably, taking more steps with this than I need to, but hey, let's just roll with it. So initial, okay, and so initial velocity of torpedoes with respect to Luke is 240 I hat, and initial velocity of the Luke with respect to the Death Star, actually constant velocity, was 160 I hat. Okay, so initial velocity of torpedoes with respect to the Death Star is 400 I hat meters per second. So that means they're going 400 meters per second horizontally. No vertical initial velocity, so very easy to just say, they don't accelerate horizontally. The only acceleration is downward due to gravity. So it's easy to just take this 400 meters per second they move and multiply it by the time it takes, and then you get, you get what you want. So equals speed of the torpedoes with respect to the Death Star, or velocity of the torpedoes with respect to the Death Star in the x direction, times t. Okay, which is 400 times 1.55, which equals, and let me just do my calculator, I should be able to do this in my head, but whatever. Okay, is going to be 620 meters. 600, whoops. Again, you'll get a slightly higher number if you used 10.0 for G. If you used 9.8 for G. I used 10.0. But that's what should happen. So if you have the Force, tell Obi-Wan Kenobi that he needs to tell Luke to fire his torpedoes 620 meters from the target shaft. And remember, as they said, the target shaft is only 2 meters wide.